Dinosaur eggs are the holy grail of paleontology. They're difficult to find, even more difficult to study, and most importantly, they can teach us so much about dinosaurs. But what exactly can dino eggs tell us? How have scientists been able to use them to learn about baby dinosaurs? And what has that taught us about dinosaurs in general? Well, join me for this episode of Paleo Logic, where we are going to talk about what secrets dinosaur eggs hold and how paleontologists are working hard to uncover them. Dinosaurs are one of the most popular groups of prehistoric animals for obvious reasons. They were large, often colorful, charismatic reptiles that ruled the Earth during the Mesozoic era, only to be wiped out by an asteroid impact some 66 million years ago. While dinosaurs capture our imaginations like few other prehistoric animals, it's important to remember that they are, after all, just fossils. And if you're trying to piece together the history of a species having only their skeletons and the rocks they were found in, is like trying to write someone's biography using only their gravestone and the dirt around it. Not exactly easy. Thankfully, though, not all prehistoric animals leave behind only their bones. Some also leave behind evidence of their life before they died, things like eggs, nests, and even skin impressions. And that is especially true of dinosaurs. Paleontologists have uncovered thousands of dinosaur eggs across the globe, and many of these eggs come from the same nest, which makes them particularly useful for answering certain questions about dino life. And while there's a lot that paleontologists can learn simply by studying the exterior of the egg itself, it's what's inside that holds the real clues to unlocking the secrets of the dinosaurs. In order to better understand what these eggs can tell us, though, we need to first ask ourselves what they are and how they got there. Dinosaur eggs are essentially the same thing as bird eggs, just much larger. The biggest difference between them is really just size. So like birds, dinosaurs laid eggs, but that's about all we know for sure about how they reproduced. Scientists do know if male dinosaurs helped care for their young, or if they were like most modern birds and left that job up to mom. It's not clear if they incubated their eggs in a nest or buried them underground, or if they did both like modern birds do. But it's likely that different groups of dinosaurs had different reproductive strategies. The good news is that preserved dinosaur eggs and nests can give us answers to those questions. Unfortunately, the vast majority of dino eggs are found without any surrounding sediment, let alone with any sign of the nest they came from. That's because eggs are extremely fragile and break apart very easily, meaning that the vast majority of them won't preserve. This means that while scientists would love to study dinosaur eggs in their nests, it's almost never possible. The only way to study a dinosaur's nesting behavior is to find an actual dinosaur nest with eggs still inside, which is incredibly rare. However, there is hope. In 2001, a Chinese paleontologist named Wang Shaolin led a team that discovered a fossil of a very well-preserved Cretaceous period nest in Ganzhou province. This nest contained at least 24 dinosaur eggs and provided the first glimpse into the reproductive behaviors of these animals. Using this discovery, scientists learned that the eggs were likely laid in a shallow depression in the ground, which would have been covered over by vegetation, creating a sort of natural incubator. While this was only one nest, and thus may not represent how all dinosaurs incubated their eggs, it's a great start to understanding what this behavior might have looked like. Even better, though, is that sometimes the eggs themselves contain clues about the behavior of adult dinosaurs. For example, in 2009, researchers used X-ray technology to look at several dinosaur eggs from nests in southern Germany. They were shocked to discover that some of the eggs contained embryos. By studying the orientation of these embryos, they were able to determine that oviraptors, the animals that laid the eggs, had likely incubated their eggs in a very specific way. They rolled them around constantly to keep the growing embryo in the correct position. This was the first time that such behavior had ever been observed in Nanavian dinosaurs, and it showed that far from being simple egg layers, many dinosaurs took great care in reproducing. But maybe the best thing that can happen to a dinosaur egg is for it to hatch. You see, when a dinosaur egg hatches, it leaves behind a hole. And while that hole may seem like nothing more than an interesting feature, it's actually a wealth of information. One of the most important things to understand about dinosaurs is how they grew. Like all living land vertebrates today, dinosaurs grew by a process called metamorphosis. As an embryo, they started off small, then grew larger, changing shape as they developed. One of the ways that we can study this growth is by looking at the interior of dinosaur eggs. When a dinosaur egg is first laid, it contains a small embryo along with a nutrient-packed yolk to feed it as it grows. As the embryo continues to grow, it eventually absorbs all of the yolk, leaving behind only a thin membrane. Eventually, the embryo is completely developed, and the final step of hatching begins. When the baby dinosaur breaks out of its egg, it leaves behind a hole with two distinct sections. The first is the area where the embryo absorbed the yolk, and the second is the area where the embryo broke through the eggshell to hatch. These holes are therefore a direct record of the final stages of growth in dinosaur eggs. Unfortunately, however, these holes are pretty difficult to study, since they usually filled in with sediment long before we ever find them. But occasionally, if conditions are right, these holes remain visible for millions of years, providing an incredible amount of information about dinosaur development. A 2013 paper, published in the journal Acta Paleontologica Polonica, reported the discovery of 17 dinosaur eggs from the genus Citipati in Guangzhou, China. Unlike most of the eggs, though, 3 of them contained these distinctive holes, which allowed the researchers to make an incredible discovery. By measuring the ratio of the 2 sections of the hole, they were able to determine that baby Citipati hatched at a length of about 8 centimeters, less than half the size of an adult. This is the smallest hatchling of any theropod dinosaur ever discovered, and it suggests that these animals experienced a form of heterochrony. If you aren't familiar with heterochrony, it's basically a fancy term for when major changes in the body take place during development. In this case, the baby C. osmulski retained its small, feathered body shape into adulthood, whereas most other theropods underwent gigantism or hypermorphosis. Basically, they kept growing once they reached sexual maturity. Heterochrony is a common phenomenon in animals today, and it's especially common among birds. It's thought that this kind of heterochrony was responsible for the evolution of flight in birds. It's possible that early birds evolved from ancestors that went through gigantism, but they retained juvenile traits, such as feathers, and a relatively small body size, allowing them to become the fastest-growing birds of their day. And this isn't the only discovery that came from studying the holes in dinosaur eggs. In another 2013 paper, scientists used similar techniques to study the hatching holes in eggs from the sauropod dinosaur Patagotitan. By comparing the size of the embryo with the size of the hole, they estimated that these dinosaurs hatched at a length of around 1.6 meters, a full meter shorter than modern giraffes. This is yet another example of heterochrony in dinosaurs and further shows that they grew up way faster than we think. What's really amazing about these studies is that scientists could gather this information without ever finding the hatchling itself. All they needed was a single intact eggshell with a visible hole, something that's much easier to find than a preserved skeleton. Of course, this information wouldn't have been possible if it hadn't been for the work of countless scientists who came before them. Studying the growth patterns of modern animals is what gave these researchers the tools necessary to interpret the holes in dino eggs. And without decades of research into dinosaur eggs themselves, they wouldn't have known what to look for in the first place. Science truly is a team effort, and paleontologists should be commended for their work in unraveling the mysteries of the dinosaurs. If you want to learn more about the science behind discovering ancient fossils, check out our sister channel, where you can watch a video we made about paleoproteomics or the study of ancient proteins in fossils. Thanks for coming along on this journey through time. See you next time.